We're now going to modify the simple exponential smoothing model to make it attempt to capture the trend. So we're going to use the Holt's linear trend exponential smoothing model to do that. So I'm going to move or copy what we just did with the sys file. I'm going to change this to Holt's linear trend exponential smoothing. We're going to change exponential smoothing to be level. D1 will be trend. I'm going to drag over this 2 places. So what we had before will now be in G and H. I'm actually also going to drag down this because we're going to include a beta. Let's lock both these in at 0.25 for now. So we want to be a forecast. So now putting in and updating formulas. We're going to initialize some values. So in cell C2, the level will be equal to B2 to start. Trend will be 0 in D2, and we'll use equal the NA function, parentheses. We won't have a forecast in the beginning for that first period, but every other period we will. Going back to level, our new formula for this is going to be equal to H1 anchored multiplied by B3, so the actual sales, plus 1 minus H1 anchored again, multiplied by the sum of C2 plus D2. So we're adding the level and trend from before in the previous period. So we'll now take this formula and drag it down, send that down. For D3, the trend function will be as follows. This is going to equal H2 anchored times the difference between C3 and C2, so those levels, plus 1 minus H2 anchored multiplied by D2, which was the previous trend. I'll now send that down. And then lastly, we have a forecast that is going to be equal to the previous period, C2 plus B2, or you can do the sum function. So sum of C2 and D2 is the previous period's level and trend is the forecast. We'll drag that down, send that down. We will now go to solver, or before we do that, alpha and beta are 0.25. The mean square error, that formula is going to change. So sales is now just going to be from B3 to B32. Before the forecast was in C column, now that's going to be in E. And our count also needs to be likewise, so I'll just drag that to sales. The mean absolute percentage error, same thing. We'll reduce it by 1 period. And this is with respect to forecast. So C changes over to E. And everything is from 3 to 32. All right, so now let's run solver. Still same objective, we're minimizing the error. Now it's going to be subject to both alpha and beta. Change your constraints to include both alpha and beta, so H1 to H2. Make sure you do that for both of them. Actually, so make sure both of them are less than or equal to 1 or greater than or equal to 0. We're going to make unconstrained variables non-negative. Let's click solve. We found a solution. You should get roughly 0.13 for alpha, and beta is going to be approximately 1. Okay. So why is that the case? Well, we're not capturing and the seasonality, which we know exists. We're going to have to do a different model to get at that. This is kind of our first step, capturing the trend as well as the level of the data. So we'll consider seasonality in a different model. One thing we want to do is we want to consider forecasts. Now, compare this with says. Let me click OK. Comparing this with the simple exponential smoothing, you'd say the error is smaller, so that's good. So we're headed in the right direction, and it looks a little bit cleaner according to the graph. This is for the Holt linear. And trend exponential smoothing. So we can generate some forecasts. So we're going to extend out the dates to March 2020. In E33 now, we're going to enter the following formula. So equal C32 anchored plus D32 anchored multiplied by parentheses. We're going to have the row function now. So row parentheses minus row of E32 anchored, and we'll end those parentheses and copy this down to give us forecasts for the next 4 quarters. So with the row function, reference is optional. If it's not given, it just returns the current row. But that helps give us formulas, or forecasts for those 4 years. And we could have used the previous formulas and dragged that down as well. But this is just a quicker way of getting at that data when you don't actually have information here.